Okay. So today I want to talk about the last part of this chapter 3 under the title of differential equations, which is actually a very, very important topic in mathematics. Most of the time we actually know the law that governs a system, but if we want to explore the system a little bit more, that law gives rise to an equation which is called the differential equation. And then we have to solve the differential equation in order to be able to understand the behavior of the system that we are investigating. Okay, but let me start with formal definition of differential equations. Okay, let me read this first, and then of course, this is a long definition, and then I will give you examples, but the topic is very, very easy. It's not hard. Of course, the topic of differential equations is a hard subject, and if you go to technical universities, you will have definitely a course under the title of differential equations separately. Okay. And by the way, in Math 5, Chapter 3, we also discuss about differential equations. But here, at the level of Math 4, you need to get familiar with the notion of differential equations. So let me read this formal definition for you first. So definition, what is a differential equation? The first sentence will actually answer this. So an equation that contains an unknown function. So here I have emphasized not an unknown number, together with one or more derivatives of that function is called the differential equation. Yes? So when you say equation in mathematics, it means that you have an equality, and that equality is sometimes true, sometimes false. When you want to solve that equation, it means that find all those values for that variable so that that equality turns into a true equality. Yes, for example, if I say solve this equation, x plus 5 is equal to 7, I am looking for a number that will fix this equality. And of course, the answer to this is just simply a number, x equal to 2. But differential equation is a little bit different. The unknown that you are looking for is not one single number, is a function. When I say a function, usually it means that I am dealing with infinitely many numbers, yes? Because for example, when you say I have a function f of x equals to x squared, this is not one single number. This is an infinite set of numbers that you assign to these functions. For example, you choose x equal to 1, the function will give you 1 to power 2, which is 1. You choose another value, you get another value, which is, for example, in this case, 4. So when you are dealing with function, you are not dealing with one single number, you are dealing with a lot of numbers simultaneously. Okay, so first of all, a differential equation is an equation, so it means that you expect to have equality sign somewhere, but the unknown that you are looking for in that equation is not a number, is a function. And in that differential equation, you have the derivative of that function involved. Okay. So let me just immediately give you an example. I will come back to this example later. So for example, this is a differential equation. Yes. Here, x is equal, so I have equality here. I am looking for a function y so that when I differentiate that function, the answer becomes 2x plus 3. So it is clear that I cannot give you one single number as the solution to this differential equation because I'm not looking for the value of x. I am looking for a function so that when I differentiate it, it becomes this function. Or for example, this is also a differential equation. So here I am looking for an unknown function with the property that the second derivative of that function is equal to the function itself. The second derivative of that function minus the function itself is equal to 0. Okay, so that's the meaning of a differential equation. Just a moment. Okay, and then another terminology. So I talked about this first part. What is the meaning of a differential equation? Then you need to know what is the meaning of the order of the differential equation. And that's also a very simple definition. The order of the highest derivative that appears in the differential equation is called the order of the differential equation. Okay, so for example, if I ask you what is the order of this differential equation, you say the order of this differential equation is equal to 1 because the only derivative that appears is y prime, and that is the first order derivative. So the order of this differential equation is 1. If I ask you what is the order of this differential equation, you would say it is 2 because the derivative that appears here, the highest derivative that appears, is of order 2. So that's also another terminology that you need to know about a differential equation. But now, what do we mean by a solution to a differential equation? Any function that, when replaced by the unknown function in the equation, turns a given differential equation into an identity is called a solution to the differential equation. I think this preposition is not correct. A solution to the differential equation. Okay, so it means that if you can find a function whose derivative is equal to 2x plus 3, that function that you are able to find is called a solution to this differential equation. I will talk about these things a little bit more, of course. And there is also another terminology that you need to know, and that is the notion of the general solution. This is also something that you need to know very well. A solution that contains as many free parameters as the order of the differential equation is called its general solution. Okay, I will come back to this point. It's not that clear what I mean exactly by this definition. It needs more explanations. Okay, for the time being, you need to know that there is a notion called the general solution, but I will talk about this a little bit later. And there are also two other points that you need to know: the notion of dependent and independent variables in a differential equation. Yes? The variable representing the unknown function is called the dependent variable. And the other variable that you are taking the derivatives with respect to that variable is called the independent variable. So, for example, if I have a function f of x equals to y, this x is the independent variable. It is free to choose whatever it wants from the domain, but y has to follow x. So, for example, if you say f of x equals to x squared, as soon as I fix my value, then the outcome of the function has to follow that value. So this value is independent. We can assign any number from the domain of the function to this x, but as soon as we do this, the outcome is determined by the rule of the function. So when I say y is equal to f of x, this y variable is dependent, and this x variable is independent. Okay. Okay, now, any questions so far? Of course, the ideas are not that very clear in this abstract definition, but by this example, it becomes clear. So if you don't mind, let me start doing the first example. And if you have any questions, I will come back and answer that. Okay. Example number 1. Each of the following equations is a differential equation. Yes. Why? Because you see all of them have an equality sign inside them. And the unknown that we are looking is a function. And then in that equation, the function and its derivatives are involved somehow. So all of them are differential equations. So here I am looking for a function whose derivative is 2x plus 3. Here I am looking for a function whose second derivative minus the function itself becomes 0. Here I am looking for a function whose derivative minus x times the function itself is equal to 0. And here usually sometimes we use Leibniz notation to denote the differential equations. This means that this function that is unknown is x, and that is the second derivative of that function with respect to the variable t. So my unknown function is x, but not as a number, as a function of t is unknown. Okay, so I am looking for a function like x of t, so that when I differentiate it 2 times and I multiply it by t cubed, it becomes this polynomial. So all of them are differential equations. So determine the order of each differential equation, and in each case specify the dependent and independent variables. Can you find a solution to each one of these differential equations? The reason that I have written can you find a solution, because solving differential equations is not actually the topic that we are going to study in Math 4. We will study a little bit of this in Math 5. But that's also help you, this kind of thinking will help you to understand the differential equation in a better way. So let us do this together. Here I have a differential equation, part A. My differential equation is y prime equals to 2x plus 3. Okay, if I ask you which one of these variables that you see is the dependent variable, the answer is what? So dependent variable is y, yes? So let me write it. Is y. And the independent variable is x. Yes, is that understandable for everyone now? Because I have written that the variable which represents the unknown function is called the dependent variable. My unknown function is represented by this variable. So that is exactly my dependent variable. And the other variable that I am taking the derivative with respect to that is called the independent variable. So the independent variable here is x. If I ask you what is the order, so what is the order? The order is the derivative of the highest one which appears in the differential equation. But you see that I have the highest derivative is the first derivative, so order is equal to 1. Okay, and then let us think about the last part. Can you find, or might be I can say, can you guess a solution to this differential equation? Can you imagine a function so that when you differentiate that function, it becomes this function?
X squared plus 3x plus c.
Yeah, so that is, what if I ask you a solution, you can just write x squared plus 3x, that's okay. So y equals to x squared plus 3x is a solution. Yes, why? Because if I differentiate this function, the derivative of x squared becomes 2x, the derivative of 3x becomes 3. But of course, you can also give me another solution. Yes, you can say that y equals to x squared plus 3x plus 5 is another solution. Yes, you can say that x squared plus 3x minus the square root of 2 is another solution. So it's clear that I have infinitely many solutions that satisfies this equation. Okay, but I have asked you to find a solution. So you can say that, for example, this one that I have mentioned here is a solution. The one that's also good that you mentioned here, you said that x squared plus 3x plus a constant c is a solution. But this is the general solution. Let me talk about this. That's also good because you brought it up. So let me talk about this. Y equals to x squared plus 3x plus a constant c is the general solution. Why is that? Let us go back here and review the definition once more. The general solution. What is the general solution? A solution that contains as many free parameters as the order of the differential equation is called its general solution. So what does it mean? It means, first of all, when you say that I have the general solution, this function should be a solution. Is this a solution to my differential equation? Yes, because if I differentiate this, the first one becomes 2x, the second one becomes 3, the last one is a constant, it becomes 0, and this would be the derivative, which is exactly this one. So yes, this is a solution in the first place, but it contains a free parameter. That is what I meant by free parameter. If I ask you what the value of c is, you don't know. C can be any number. So it is a free parameter. So this solution contains one free parameter. But what is the order of differential equation? The order of this differential equation is also 1. Okay, so I have a solution. It contains one free parameter, and the order of differential equation is also 1. So this is the general solution. So I hope that now that ambiguous part is also clear. I will come back to this again, but this is the meaning of having the general solution. But if you don't mind, let me just put this in a box because that is not part of the solution to this problem. Okay. Yeah. How much I have here. Okay, so let me save some space. Yeah, I can just clean it because this is not part of the solution. I will come back to this later. Okay, now let us go to part B. Now I want you to answer this question for part B. Here, if I ask you what is the dependent variable, what is your answer?
Y.
That dependent variable is y. So let me write dv for dependent variable is y. But if I ask you what is the independent variable, it is not that clear from the context of this problem because I don't see any other variable. When this is the case and this is not implicitly mentioned, we can assume that this is x, because usually in mathematics, y is a good representative of the dependent variable, and x is the independent variable. When you talk about a function, you say, for example, y equals to x cubed. Yes. So if this is not explicitly mentioned in the problem, you need to assume that that independent variable is x. So independent variable, dependent variable. But if I ask you what is the order of this differential equation, make sure that you don't say degree. Degree is not this. So this is important to say the order of this differential equation. So what is the order of this differential equation?
2.
It is 2, because the highest derivative has order 2. Okay, now can you guess here a function with this property? A function so that when I differentiate it 2 times and subtract the function itself from the derivative, from the second derivative, it becomes equal to 0.
E power x.
Yes, e to the power x is a very good candidate. Can you guess another? So let me write some of them. So y equals to e to power x is a good candidate. Everybody agrees, yes? Because if I ask you what is y prime, you would say e to power x. If I ask you what is y double prime, because it becomes exactly the same function, it is clear that if I subtract these two functions, the answer becomes 0. So this is a very good, this is the complete correct answer. But can you think of another function with this property? Is there any other one?
Maybe 0 to power x.
Yeah, yes. So 0 is also, so yes, 0 is actually a solution here. The function y equal to 0 is also a solution here. That's also correct. So, but I understand, but can I say that this is the general solution? How many free parameters? No, how many free parameters should be involved in the general solution to this differential equation?
2.
2. Why? Because the order is 2. Yes, we will come back to this later. Okay, so that's correct. Now, if I go to the other one, part C, what is your answer for these cases? So dependent variable. So dependent variable is what? Is clearly y. Here it is explicitly mentioned so that the independent variable is as before x. What is the order? The order is, what is the order?
1.
Yeah, the order is 1. And then can you guess a function with that property? You need to guess a function so that when you differentiate it, and then when you calculate this and subtract these two, it becomes equal to 0. In principle, you want to imagine a function so that its derivative is x times the function itself. You need to somehow guess this function. Of course, solving differential equations is not an easy task. And let me just mention right here that most of the differential equations that appear in science and engineering we are not able to solve them analytically. We have to solve them numerically by approximation methods. So this is why most of the differential equations are not soluble analytically, of course. And then even if we can solve them, this is not part of your lesson, except for very simple equations that you somehow can guess or you can solve them systematically. We will study this a little bit more systematically in Math 5, Chapter 3. Okay, I'm just waiting. Can you guess a function or can you do something to be able to help you to guess the answer to this differential equation?
It might not be the most correct answer, but y equals 0 works.
Yeah, y equal to 0 works. Yes, that's clear. But except for this trivial solution. Yes, let me write this, by the way. This is not wrong. Y equal to 0 is one of them. Everybody agrees that. If I put 1 here, 0 here, the derivative of 0 is 0. Here also 0, so that's a 0. But can you guess a little bit more interesting answer to this one as well?
Maybe y is 1 over x. No, wait, that doesn't work.
No, y equals to 1 over x, I don't think. Let us see if it works or not. Y equals to 1 over x. Let us take the derivative. Do you remember the derivative of this one is minus 1 over x squared? Yes? But if I multiply x by y, the answer is 1. So if I subtract these two, the answer is not 0. So y equals to 1 over x does not work. for this case, I think it will work. Yes, let me just write it and then I will clean it. So here, if the equation was this equation, I think then you are right. Let us double check this one. You see, here I have a negative sign. If I had a positive sign, I think your answer is now correct. Let us check it again. So here you said 1 over x. Let me remind you, if you have forgotten, how I differentiate this. So first I need to bring it up. It becomes x to the negative 1. Then I differentiate it, so it becomes minus x minus 2. So it is minus 1 over x2. And then the left-hand side is equal to, instead of y prime, I put this. No, this one also doesn't work. Yeah, it doesn't work, sorry. Because it becomes minus 1 over x squared. And then if I have x times y, it becomes plus x times 1 over x. I miscalculated in my head, so it becomes 1. So it is not equal to the 0 function. So it is not also working for this case. Okay, any ideas? Think of an exponential function with base the Euler number. Couldn't guess? Okay, so let me write it. The first thing that I guess is something like this. But of course, I need to adjust a constant. So do you agree with me more or less? If I ask you, I hope that you haven't forgotten. If I ask you to differentiate this function, how do you do that? If I want to differentiate this function, you need to take this u in your head. So it becomes e to power u prime, chain rule. It becomes e to power u multiplied by u prime. So it becomes e to power x squared, but u prime is 2x. So you see, it is 2 times x times my function. Yes, but unfortunately, I don't have this 2. So now can you say what I should write here so to make up for this extra 2 that I don't need? Isn't it clear?
We put a 2 in front.
Not 2.
No, 1 over 2.
Yeah, exactly. 1 over 2. So let me clean this and let me write here 1 over 2. Let me double check. So the one that Luve told is correct, but this is a trivial solution. A more non-trivial solution is this equation. Let us double check. Now I want to check that this is indeed a solution to this differential equation. What should I do? I need to differentiate this function. I differentiate it. 1 over 2 is a constant. If I want to differentiate e to power x squared, so let me write it step by step. This becomes e to power x squared multiplied by the derivative of x squared, which becomes 2x. But this 1 over 2 and 2 will cancel, so I will get x e to power x squared. Okay, now what is the left-hand side? The left-hand side is y prime minus xy. Instead of y prime, I put this. It becomes x e to power x squared minus, I have x, so let me copy and paste x, but instead of y, oh, it doesn't work again. No, it doesn't work, yes. So let me see if I want to solve it. Let me cheat a little bit because I know how to solve it. So y prime y is equal to x. It tells me that e to power x is also an answer to this, is it? I don't see that. Okay, no, okay, so this is not the correct answer. Sorry, I confused myself. It was not that easy that I guessed. Now I know the answer. The answer is not this. So let me just write the answer. Sorry for this example. I thought that this is the answer. This is not the answer. At least you understand that this is not the answer. Do you agree with me? Because that was my guess. Now let me show you that this answer is not correct. What I need to do, I differentiate this function. I got this. But when I replaced y prime by this expression, and then I have to write minus x times y. But if I multiply x times y, I will get this, which is not 0, because this expression is half of this expression. So if I subtract them, it becomes 1 over 2 e to power x squared, which is not equal to the right-hand side, because the right-hand side is equal to 0. And this is not working. Sorry, so that was my bad. But now I can correct it. So is there any question? Everybody understands that what I have written here is not a solution, even though it was not the goal of this problem. Everybody understands that? Okay. Now I will correct this. This 1/2 shouldn't be here. This 1/2 should be up there. Okay, so now let me now double check this. Okay, so if I ask you to differentiate this function, let us do this. Y prime is equal to e to power 1 over x squared prime. This becomes equal to e to power 1 over x squared multiplied by the derivative of u. But what is the derivative of u? 2 goes down, will cancel that 1/2. It becomes just simply x. Now you see that that is correct. Yes? So now, which is equal to, this one is again y. So this becomes equal to xy. So I realize that if I take this as my function, when I differentiate it, it becomes equal to this, but this part is y, so it becomes x times y. So it means that this function, the derivative, is equal to x times y. Therefore, if I subtract them, it becomes 0. So that's correct. Okay, sorry for this mess. Hopefully you are not confused. If you're confused, please ask questions. Okay, good. Okay, now let us do the last part, part D. What would be the order and what are the dependent and independent variables? And let us see if we can find a solution to this one as well. Okay, so help me to do that. So let me write part D. What is the dependent variable here? Can you tell me?
T.
Dependent variable. Dependent
Oh,
variable.
Sorry.
Yeah, what is
dx
that?
over dt.
No, dependent variable. Dx over
Yeah.
dt, the function.
But
Which one? So how many variables you see here?
oh, x is the dependent variable. I'm sorry. Two
Yes.
variables.
So we have two variables, x and t, but the dependent variable is the name of the function which is missing and you are looking for. Okay, so this is the dependent variable. Here, x is not known as a function of t, because you see, when you see this symbol, it means that I am differentiating x when t is my variable. So it means that the function which is missing is a function x of t. X is the dependent variable, t is the independent variable. Yes. So dependent variable is x, independent variable is t. And what is the order? Can you tell me? What is the order of this differential equation? Do you recall what is the order? The highest order derivative, the order of the highest derivative.
It should be 2.
It is again 2, because if I ask you what is this, you would say this is the second derivative of x. And that is the highest derivative that appears in this equation. So again, the order is 2. But guessing is a little bit hard. Can you just tell me how systematically we can come close to a better way of guessing the solution, a solution? I am looking for a function x, a function of, for example, x of t equals to t squared. X of t equals to t to the power of 2 plus 2. These are functions of t. Which one of them will fit this? It is not easy to guess immediately, but you can do something with it so that the guessing procedure is a little bit easier.
We divide both sides by t
Yes,
cubed.
yes. Yeah, that's very good. Assuming that t is not 0, of course, I can divide by t to the 3. The left-hand side becomes this. So I divide everything by t to the 3. This t to the power of 3 is cancelled. When I divide this by t cubed, it becomes 4t. If I divide the other one by t cubed, it becomes just simply 2. Now I think it is not that hard to guess because that's a polynomial. You want to find a function so that if I differentiate it 2 times, what is left for me is this one. Okay? So how do you think about the problem? So for example, you might say that I am looking, can you tell me from here to here is not hard to guess. Can you tell me what do you expect from the first order derivative if the second order derivative is going to be this function?
2t squared plus, let's see,
Yes, 2t squared plus?
wait,
That's correct. 2t squared plus t, yes.
Yep. No.
This is one possibility. Sorry, plus 2 plus 2t. Yes. So is that understandable? Because if the first derivative is this function, I'm not saying that this is the only possibility, but that is one possibility. If the derivative of the function is this, it is clear that the second derivative becomes this. But now again, it is easy to guess the original function. Now you want to guess a function so that when you differentiate it, it becomes this. Of course, you know the notion of primitive functions from Math 3C, but because this is the notion of the next chapter, I don't want to use that concept, but you can use it if you want to. So can you guess the function itself now? You want to guess a function whose derivative is equal to this. Can you have a guess?
2 over 3 t cubed plus t
Yes.
squared.
T squared, yes. So that's also one possibility. Hopefully everyone agrees that if you take the derivative of this function, it becomes this. And if you take the derivative of this function, it becomes this. So this is a solution. It is not the general solution. It is one of the possible solutions to this differential equation. Okay, Hopefully everything is now clear. Let me go to the next page. Here I have written more complex differential equations. If you ask me, can I solve these differential equations? Most of the time, no. The answer is not clear that how should we solve these complicated differential equations. But I just want to see that differential equations can be quite hard. And I told you, most of the time we cannot solve them analytically. So for example, here, this is a differential equation. Let us review everything together. Here, y is the independent variable. Sorry, y is the dependent variable, x is the independent variable, and the order of this differential equation is 2, because the highest derivative that appears, I have two derivatives here. One is y prime, the other one is y double prime. But the highest order derivative is of second order. So this is why we call this differential equation a second order differential equation. If you have any questions, please interrupt me. So here, that is also a horrible differential equation. And if I ask you what is the dependent variable, it is clear. I am taking the derivative of the function y. So y is the dependent variable. X is the independent variable. And if I ask you what is the order, what is the answer? What is the order of this differential equation?
3.
This is 3, yes? I have 3 derivatives involved. One of them is the first derivative, the other one is the second derivative, and the other one is the third derivative. So the highest order is the third derivative. So the order of this differential equation is 3. So for example, here, I have a differential equation, and then y is the dependent variable, x is the independent variable. And if I ask you what is the order, I hope that you remember this symbol, that when you put 4 in brackets on top, this is not power, this is the order of the derivative. So the order of this differential equation is 4, because the highest order derivative is 4. And if I come here, if I ask you what is the dependent variable, you will say y. What is the independent variable? It is t in this case. And what is the order of this differential equation? Is 3 again. And if I come to the last one, if I ask you what is the dependent variable, can you answer? What is the dependent variable in this differential equation?
X.
X. And what is the independent? It is t, and the order is
1.
the order is 1, yes. But of course, I just wrote them to see that the differential equations could be quite complicated. Okay. And now this is our last example here. This is the type of example that you need to know very well for this. In this part of the book, you are not supposed to solve differential equations unless they are easy to guess, or I give you some hints how to guess in the exam. But this part is a very important one. So if you understand this, it means that you are on the safe side. Okay, so let me read and solve it, and then we finalize, we discuss about the exam, okay? Show that y equals to a times x cubed plus b over x for any real numbers a and b is the general solution to the differential equation this. This preposition of is not correct, you should say too. So is the general solution to the differential equation, which is written here. Of course, they want to be precise, so they have mentioned on any interval not containing 0. And the reason is clear, because if x is equal to 0, this part doesn't have any problem, but this part is problematic, yes? The denominator cannot be 0. This is why they emphasize that on any interval not containing 0. Okay, moreover, with the help of the first part, determine a solution to this differential equation for which y of 1 is equal to 2 and y prime of 1 is equal to -6. Okay, So let us solve this problem. Okay, can you help me? What is the first thing that I have to do? Yes, I want to show that this is the general solution to this differential equation. What is the first step? What is the first step? The general solution should be at least, should be a solution in the first place. So first thing that I have to do is to show that this is indeed a solution to this differential equation. Then I have to discuss about the number of free parameters and compare it to the order of the differential equation, which is of course the most easy part, the easiest part. Okay, how should I do that? If I go to this differential equation, I see that I have my function. I don't have any problem with that. This is directly given. I have the derivative of the function. I also have the second derivative of the function. Okay, so let me do these derivatives. So I have y equals to ax cubed plus b over x. If you want to, of course, you can use the quotient rule to differentiate this one. But I told you that whenever it is possible to avoid using that complicated formula, I would prefer to do that. So before starting differentiation, I change the form of this function. It becomes ax cubed, and instead of b over x, I write b x to the power of minus 1. In this form, it is much simpler to differentiate. Okay, now everybody can differentiate this simple function. So the y prime of x is equal. It is mentioned here that a and b are real numbers, they are constant. So when I want to differentiate this, I don't do anything with a. The derivative of that one is 3x squared. And then I don't do anything with b. The derivative of x to the power of minus 1 is minus 1x to power minus 2. So let me simplify this a little bit. I write it in this way. This is my first derivative. But you see that you also need the second derivative. You do another one. So this becomes 6ax. It becomes positive 2b. X to power 1 unit less, which becomes minus 3. Now everything is ready. I have y prime, I have y double prime. So here I want to show that the left-hand side becomes equal to the right-hand side. So I think it is easier to do like this. I calculate the left-hand side, I calculate the right-hand side, and then compare them. So the left-hand side is x squared y double prime. So this means that x squared, instead of y double prime here, I put this expression that I found. And then I multiply x squared inside. Yes? When I multiply x squared by x to the power of minus 3, it becomes x to power minus 1. I cannot go any further, so let us keep it as it is. This is my left-hand side. Now let me go to the right-hand side. The right-hand side here is this expression. Right-hand side here is this expression. So it becomes, let me write it again in front of our eyes. Okay, what should I do? I write x, but instead of y prime here, I put this expression that I got. And then I have plus 3 times y. This is my y, but y is exactly the same expression. This is my y, yes? So it becomes ax cubed plus b over x. And then I have to simplify this. I multiply x inside, it becomes 3ax cubed minus bx to the power of minus 1. The next one becomes 3ax cubed plus 3b over x. Okay, but how can I write this? This one plus this one becomes 6ax cubed. And actually, these are the same two expressions, yes? Another name for this is, instead of this, I can write it in this form. And then I have plus 3bx minus 1. One of them is gone, so two of them is left. So it becomes plus 2bx minus 1. So if I call this one number 1, and I call this one number 2, just compare these two. They are exactly the same. Yes, this one and this one are exactly the same. So if I compare 1 and 2, then I conclude that the left-hand side is equal to the right-hand side. So therefore, y equals to ax cubed plus b over x is a solution. But this is not finished. We are supposed to show that this is the general solution. You need to write it in words. Why do you think that this is the general solution? Can you comment on that? Why this is the general solution?
The number of free parameters is equal to the order of the differential equation.
Exactly. How many free parameters you see here? A and B are not fixed, they are free. So I have two free parameters. What is the order of my differential equation? The highest derivative that appears there is 2. They are the same. On the other hand, this is a solution, so this is the general solution. This part you have to write in words, okay? So therefore is a solution. On the other hand, this solution contains two free parameters, A and B, which is equal to the order of the differential equation. So let me write DE for differential equation for short, for the differential equation. Thus, this is the general solution. Okay, and now let us go to the last part. In the last part, we are supposed to determine a solution that satisfies these two conditions. So it means that when you replace x with 1, the answer becomes 2. And if you go to the first derivative and replace x with 1, the answer becomes -6. So it is clear, I use these two pieces of information to find my free parameters A and B so that these conditions are met. Let me see if I can, yeah, let me take this with me to the other page. Okay, so here, let me just put it here in front of our eyes. Let us do the last part of the problem. Here, y of 1 is supposed to be equal to 2. So it means that if I go to y and replace x with 1, the answer is supposed to be 2. So this becomes a times 1 to the 3 plus b divided by 1 is equal to 2. So this means a plus b is equal to 2. Okay, now let me go back to the previous page because I need the derivative as well, but I have done it here. So if you remember, this is my derivative, so let me take this one with me. So here we have this derivative. Now we know that y prime of 1 is supposed to be minus 6. So it means that if I replace x with 1, the answer is supposed to be minus 6. But if I simplify this, this becomes minus b is equal to minus 6. 1 to the power of minus 2 is exactly equal to 1. And then I have a system of equations. A plus b is equal to 2. 3a minus b is equal to minus 6. I solve this system. It's easy. I add them. It becomes 4a. b and minus b are cancelled. It's minus 4. So a becomes minus 1. So that is the answer to a. And then, for example, I take this a and put it here and find b. So this becomes minus 1 plus b is 2. So the answer is b equal to 3. And then the answer to this problem, I need to write it, is y equals to, instead of a, I put minus 1. Instead of b, I put 3, and then I am done. So this becomes minus x to the 3 plus 3 over x. This is the answer to the second part of the problem. Okay, any questions? Is it clear? Okay, so now I can stop this video